Hello everyone, in today's video we're going to look at expressions. An expression in F# is a collection of values, variables, functions, or operators combined together to produce a definite value. For example, if we had an expression like this, 2 plus 2, right? We're combining two values, 2 and 2, and we are using an operator to join them together. And more importantly, this whole phrase, if you will, evaluates to a definite value, say 4. So it's coming. Say 4, right? So this is considered what? An expression. You can combine two expressions together. So we're using the semicolon. So for example, if I came here and added 3 times 2 and added another semicolon, and I highlighted that, you can see that the two expressions were combined together. Now what F# does is it evaluates the first expression, and then the value of the combined expression is the value of the last expression that was combined together. So the value of this entire expression is 6. So if I highlight all this and execute it, you can see it's saying 6. Now in F#, the semicolon is actually a substitute for a new line. So a new line is another way of combining expressions. So if you put an expression on the next line, it's assumed that there is a semicolon in between. So if I were to highlight these two and execute them, you can see that the answer is still 6. This is really useful because you could have like a let binding. So you can say let A equal to this, and you can have something like this. But as you can see, it's immediately warning us that this value is actually ignored. So that now brings us to a special value in F# called unit. Okay, so in F#, this value called unit is a single value represented by braces, right? It has the type of unit. So for example, I were to come here and say let Z be equal to this. You can see that it's saying that it's saying that the value of Z is unit. Okay, even if I put my mouse on it, you can see saying is unit, and that now means that so unit here represents the idea of nothing, not null, nothing. So like void in other languages. In F#, all expressions must return a value. It's a must. It has to return a value. So expressions that don't return values return this magical value called unit instead. So this is a very key thing to remember. This is important because unit is like any other value, and like we looked at in the previous lessons, you can have something like array of units as well. So if I did this would be comma, sorry, not comma, this would be unit array. So that is something to keep in mind. Now, because unit is a kind of value, we don't need to actually assign it to a named variable. So, just assigning it to Z here is actually overkill. We could replace this with a do keyword. So the do keyword is telling us that the expression coming after it is going to return unit. So it doesn't matter. We're not really assigning it. The do is essentially anyway you can put a let statement, you can put a do statement. The difference is with a let you must assign it to something, whereas with a do it just expects that the expression that's coming after it is going to be unit, or is going to evaluate to unit, so it doesn't matter. Okay, then an example of an expression that returns unit is an assignment operation. So let's say for example I had something like this: let mutable Z equal to 1, and I now said Z changing Z to 2. This whole expression has the value of unit. So if I came here and said Y, you can see that the value of Y is unit. That also now means I can just say do like this. For the most part, it's overkill to put the do statement in front of assignment operations, because F# automatically knows what to do. But there are certain scenarios which we will get to in future where that do becomes important by the time we get into object-oriented programming in F#. But that's still down the line. So the first type of expression we're going to look at today is called the if expression, and it essentially allows you to make like decisions with your expression. So an example of this would be something like this. So let's say I said let x equal to 10, and I said if x is less than 5, then return a string that says less than 5. Otherwise, else it should return a string that says greater than 5. Okay, so if we highlight this and run this, you can see it's saying greater than 5. Now the way it works is when you use the if statement, the if expression, you have to supply a condition a condition expression that can return either true or false. And then if it's true, then this becomes the value of the whole expression. Whatever you put in the then, whatever expression is put in the then section becomes the value of the whole expression. But if it's false, then the else part of it gets executed. And because the entire if expression is also an expression in itself, I could assign it. I could assign it to a value. So I can assign it to text. And then, if I wanted to see the value of text, I just highlight this and execute it. Okay. See, the value of it is saying greater than 5. If I were to change 10 to 2, for example, or 1, and I highlighted this and executed it, it will say less than 5. Okay. That is essentially the if expression in a nutshell. In F#, both branches of the if expression must be of the same type. So I can't essentially come here and just say 10, for example. This won't work because these two branches of the expression need to be of the same type. That's a very key important distinction. Otherwise, it wouldn't know what to assign to text, whether I should assign a string or should assign an integer to it. Okay. There is one exception though, or slight exception to this rule, and that's when it comes to units. So say for example I had if x is greater than 10, then unit, I don't need to specify the else branch. And the reason for that is that, let's say I say unit text unit if, and the reason for that is because the compiler automatically just comes here and just adds else unit for me automatically. This can be useful if, for example, I wanted to mutate a variable. So let's say let mutable, let's call this z equal to 1, and let's say I just assigned z to 1, right? Because this evaluates to unit, then the whole thing evaluates to unit. Okay. So the next type of expression we're going to look at is called the match expression, and the match expression in F# is one very powerful tool in F#. Is probably one of my favorite F# tools, and let's see an example of what the match expression looks like. So say for example I had a value like this, z equal to say 15, and I wanted to match, let's not make it 15, let's make it like 3, right? I could say match z, so I have to specify an expression that I want to match on. So this expression gets evaluated, and I use a with, and I put a pipe, and I specify what I want to match it with. So I could match it with 1 and say one. I can say 2 two, and I can say 3, and finally I can put a wildcard character here. So I can say neither 1, 2 or 3. Okay, now let's take a very good look at this. What's going on here is that essentially, like I said, it evaluates the value of z, it comes here, matches it with 1, and if it's a match, it goes ahead and evaluates this. Otherwise it tries 2. If it doesn't, if it tries 3 and that evaluates, then this becomes 3. Now if I didn't put this last section here, you will notice that the compiler gives me a warning. So it's saying incomplete pattern matches for this expression. So it's saying essentially that I have matched on some of the cases of some of the possible values of z, but I have not matched on all values of z. So for example, the value 0 is a case that's not covered. In other words, I've not covered what happens if z is 0, which is a very useful error message, because it's like you're having a conversation with the compiler. The compiler is giving you hints as to, okay, you've not thought about this, you've not thought about that, and that is very, very useful. In fact, it's one of the most powerful features in F#, because it prevents you from having to deal with writing programs that have like leaky cases that you didn't think of, and at runtime it starts to fail or whatever the case may be. So in order to circumvent that, right, I couldn't obviously have a case for every single integer. So in order to circumvent that, you use something called a wildcard pattern. So this is another example of a pattern that we've looked at. In fact, up until this point, we've looked at the following patterns. We had the tuple pattern, so something like a comma b. We've had the wildcard pattern, which we just learned. So this wildcard pattern essentially just matches any kind of pattern, and this is one of the reasons why as we go along and as we come across new patterns, I'll make sure to point them out. So this pattern just matches anything, any and everything. So for example, it matches all other possible values of z, and in those cases this now becomes the value of this entire expression. So let's go ahead and assign this to result. Let's go ahead and assign this to result. And now if we run this entire code, we should see that the answer is what? 3. The value of this expression is 3. T-H-R-E-E. So one other thing that I wanted to also mention is that in F#, you can filter patterns with a filter clause or a guard clause. An example of this is, let's say we wanted to find out if numbers are, so we're saying let number equal to 25, and I was to say to find out whether it is an odd or even number. So one of the ways I can do this is to say match number with and here I can specify something called a variable pattern. So what that does is it just binds essentially binds this value, the value of this expression, to this identifier here, so that I can use it within that particular match clause or match case. Okay, so here we say if x equal to 4. So for odd numbers, even numbers, so odd numbers, yes, let's use odd numbers. So for odd numbers, we want to match the value of x whenever x is, when we divide x, whenever we take the remainder of dividing x by 2, and if the remainder is greater than 0, then the number is odd, otherwise the number is even. So this is one way of doing it, and as you can see here, it's showing us essentially that let's go ahead and evaluate this. You can see that it's saying that the number is odd, so 25 is odd, which is really, really cool. So that is it for match expressions. The next thing we want to look at is repetition. How do we do repetition in F#? And the way you do repetition in F# is using the one of the ways you do it rather is using the for expression. So let's look at that. So if you say let mutable total equal to 0, or rather I can just copy this in. Yeah, so what is going on here is we come here and you have your identifier that you want to be using within the loop. You have your start value and you have your end value. So what is going on here is that it's going to start with 0, it's going to increment 1 until it gets to 10, and then while it's doing that, it will evaluate this expression. So the very first time when I is equal to 0, it's going to come here and just add 0 to the total, which is 0. And then the second time it's going to increment I with 1, and the new I becomes available here in this expression, and then this becomes total plus the new I, which is 1, and total becomes 1, and like that until you get to 10, and that's how you have the total. So if we go ahead and run this, Alt enter, we should get 55, which we do. Okay, we could also reverse the order in which we moved through the elements. So one way to do that is to say 10, and this time we'll say down to 1 or 0, whatever. And this time if we run it, we should also still get 55 as well. The only difference is that this time the order was reversed. So it starts with 10 and goes all the way down to 1, which is pretty clear and simple. The next thing we're going to look at is the second form of the for statement. So in this particular case, right, we moved from 10 down to 1, essentially just incrementing a value and all that. So we're kind of limited in the kind of iterations we can do with this. So the F# produces another form of the for statement, which is this. So what this does is just to say for I, which is your identifier in any particular sequence. So if you remember, we talked about ranges. We worked with ranges. So if I did this, let z equal to this doesn't work. I have to put it in some kind of, yeah, and we have an int list now. You can see that's a recap from the previous lesson, but essentially you can essentially put a range here, and the compiler will just loop through the elements of that range, which is 1, 3, 5, and 7, because we said start with 1 at increments of 2 and stop at 10. And for each of those times, it's going to go ahead and add that to the total. So this should give us 25. And yes, it does give us 25 because that's the total sum. Now, the issue with the for looping and all that is that it's kind of is bounded. Bounded means that it has a definite start and a definite end. What if that's not what we wanted? What if we wanted a kind of looping structure that would just go on forever until we say so, until we say stop, right? And that's where the while loop comes into play. So an example of this is to say while you cannot have your I less than or equal to 10, which is your condition. So this is the condition we want to hold the loop at. We can now perform this too, and whenever this condition changes, that is when this loop essentially stops. So we're starting with I equal to 1, and we're starting with a total of 0. So while we check is I less than 10, if that's true, then we increment the total, and then we increment I, we increase I by 1. So we do that, and that becomes 0 plus 1 plus 2, blah blah blah, all the way to 10. And if we run this, you should see, let's run this, you should see that the answer is 55 as well, which is cool. Now, one of the important things to note is that if this expression never becomes false, this loop will actually run forever, and to actually hang the it will actually just hang your program. Your program won't be able to run because it will essentially just be looping and looping and looping and looping without end. So if I say while true, do x equal to 10 for whatever, just or I could say total, because I can still reuse total plus 100. So if I do this, total plus 1. So if I do this and I run it, you'll see that FSI just becomes stuck all of a sudden. Yeah, so in order to prevent that, always make sure that your while loops essentially will terminate after a while. So that almost always means that there has to be something inside of the body of the while loop that forces this, that could make this condition become false. So always check for that. So in all the previous examples, right, we had to use lots of mutable variables in order to do looping and all that. And in functional languages, right, mutability is allowed, but is usually not the way things are really done. So more often than not, what we use the looping expressions to do is to generate something called sequences, to generate like data structures, like lists, like arrays, like sequences and all that. We'll get to sequence in a moment. But an example is this. So here we use the yield keyword, right? So instead of incrementing a value, so if you remember, so instead of having to mutate a total each time we went through the loop, right, we can simply just use the yield keyword. This yield keyword just returns the value out and adds it to the sequence. So for example, if I highlighted this and ran it, you would see that, okay, you've seen 0, 1, 2, 3, 4, 5. Yes, so that is one way of building a sequence, right? And because this idea of using a this for in construct and using do yield is very common, one of the ways it can be shortened is to just use it use an arrow here. So these two are exactly the same thing. All right, there's no difference between using do yield or just using the arrow, and this makes it really easy to wrap your head around. So for example, I could if I wanted to get a number and all the squares, I could say something like for I in 0 to 10, 0 to 10, and this time I'll say I comma I times I. Right? So what this will do is it will generate tuples. What this will do is it will generate tuples, and as you can see, this is 0 0 1 1, so a number and its squares. Okay, so this is a very, very succinct way of writing it. You can also have while loops inside of sequence expressions. So an example of this would be something like this, where we're using a while loop and we're just mutating a variable outside and we're just yielding the value out. The point is, you can put any kind of looping structure, any kind of looping construct inside of this square brackets, and it will generate a list for you. So if I were to run this, you will see that you can see 2 3 4 5 6 7 8 9 10, and if I also wanted to create it as an array instead, all I just needed to do is just put the square brackets in front, and this is an array as opposed to a list, and so on and so forth. So those are list expressions. Finally, we're going to look at sequence expression. A sequence expression is a lazily evaluated series of items of the same type. Lazy evaluation means that each value of the sequence is only produced on demand. In other words, the compiler, the runtime, doesn't evaluate the entire sequence all at once. It just it's only when you try to enumerate over the sequence that it actually generates values. So an example of this would be something like this. It looks very similar to our example is something like this. It looks very similar to our list comprehension. The only difference is that yield. Yeah, the only difference is that the we have this SEQ in front, and even the way it's represented in F# Interactive gives you a hint as to what's going on here. So if you notice, there is a ... So what's going on here is that it just knows that this sequence could go on forever, so it just adds the ... to just tell you that this just moves on. Okay, that's what a sequence is. Technically speaking, all the other types of sequences we've looked at, like lists, like arrays, they are all sequences as well, but this is the more general form of generating a sequence. And like I said, a sequence is lazy. So unlike lists, which are eagerly evaluated, a sequence is lazily evaluated. And an example of this would be, say for example, I were to write a very malicious code. So I said while true, do yield Batman forever, right? So if I were to evaluate this, right, immediately FSI hangs, and the reason it's hanging is because the runtime is trying to evaluate this looping expression. So while true is never going to become false all of a sudden, so it's going to keep yielding Batman forever. So this essentially just breaks FSI. However, if I were to change this to sequence, right, if I were to change this to sequence and I was to execute this, you would see that, yeah, it actually just says Batman forever like 4 times, and after that just puts ... So this means that, you know, the sequence can be, you can have infinite sequences. That's essentially what it means, and you can store them and use them as normal values without, you know, having any problems. You know, as long as the consumer doesn't just keep looping, keep going over the sequence forever, everything will be fine. So this is really helpful and really useful, because there will be algorithms you write where you don't want to where you want to just produce an infinite sequence, and you want to leave it up to the consumer of that sequence to decide whether they want every item in the sequence or whether they just want a subset of the item, like what's going on here. So that's a key important distinction. So I think that's it for today. This video is I try to make it as short as possible to keep your attention span. But I hope you learned something about like expressions in F# and the different types of expressions and how you can use them, how you can combine them together and stuff like that. So see you next time, and bye.